One.
Hey, hello, thank you for attending this presentation. My name is Inigo Gisbert. I'm the design director at Aurum Bikes, and we're going to talk about the development and some design features of the Aurum Magma bike, which I have right here next to me. You have just seen the presentation from Alberto and Ivan about the brand, and a little bit what was their goal, their idea for this bike and for this brand in general, and this bike. So Aurum is a brand born from experience. It's the experience of Alberto and Ivan as bike riders, and also the experience of the people that they have, the team they have created to develop this bike and to manufacture this frame and fork and some other parts. There's the drive of the development of this bike was about balance. Was the balance between different riding characteristics and also geometry, a balanced geometry. This is a race bike, but it's balanced for comfort and for adjustability, as I will explain in a moment. So for the riding characteristics, which was really what Alberto and Ivan were more focused on, more interested to develop when they decided to create their own brand, we focus on 4 different characteristics: stiffness, comfort, aerodynamics, and lightweight. And it was very important for Alberto and Ivan to really balance these 4 characteristics, not to stress any of them too much. So they are all at a very high level. This is a high performance bike, but we didn't only focus on aerodynamics or only on lightweight, but it's the balance, is the balance that really defines this bike. So when we started this project a little bit more than 1.5 years ago, the first discussions were about geometry, because geometry is the soul of the bike. So it's really what defines the handling and the behavior of the bike. So both Alberto and Ivan, they raced in a few different teams, all top level teams obviously, and they use top level equipment. But it was always in their minds, they always have this idea of how it would be if they could really create the best bike as they think about it, right? As they understand it. So geometry was the starting point for that, and we really went through all the bikes they have been riding through the years, and compiling some information and looking at what made this or that bike great, what was not so good, and then writing some of these bikes to really analyze that and put on paper and make a list, right? So based on that, that's how we came up with the geometry you can see now for the Aurum Magma bike. And one very important point was to achieve this same handling characteristics for all sizes, for all 6 sizes of the bike. Alberto rides a size 54, Ivan rides a size 56. He's in between a 56 and a 58, but usually he rides a 56. So they knew those bikes very well, but from their experience riding in different teams with different teammates, different heights, right? Shorter riders, taller riders, lighter, heavier, and also because of the development team that Alberto and Ivan they run now, there's a variety of riders there. So it's very important that the geometry was balanced for all of them. Usually the development of bikes starts from the middle sizes, which is exactly what Alberto and Ivan ride, like a size 54, a size 56. And then when you scale this up or down, then things can go a little different, right? Especially for the shorter, for the smaller bike sizes, because you're trying to squeeze those 700C wheels in a smaller frame, and for that, if you want to have if you are trying to have a proper fit for the rider, then very often what happens is the handling gets a little compromised. Usually, in order not to have a toe overlap, then many bikes, they have a very slack head angle for the small sizes, or some other things that are not ideal. So we really work on the numbers, and we could see one key number, of course, key dimension is the trail, the fork trail, which is the combination of the head tube angle and the fork offset. So for the Aurum Magma, we have two different fork offsets. The smaller two sizes, they use a 50mm offset, and the other sizes, they use a 44mm offset. With that, and a careful choice of the head tube angle and the front center, then we can achieve a trail figure of around 59mm, which is ideal. It's an ideal balance. It's the balance that Alberto and Ivan thought it was the best compromise between very quick handling and tight cornering, but also stability at high speeds. This trail figure is based on a tire size from 25 to 28mm wide, which is the modern standard for tires now. That being said, the frame and the fork, they can fit up to a 30mm tire, but the geometry is optimized for tires between 25 and 28. So when working the geometry, for the handling, the work was on having some balance characteristics, as we said. For that, we also work on the BB drop. So the BB drop is 71mm for most of the sizes, and 74 for the smallest size, which is gonna see a smaller rider. So that way, dropping the BB a little bit more, and normally using shorter cranks, we can also achieve a nicer standover height for this smaller rider. On the fit side of things, for the geometry, we have 6 sizes, and these go, the number we use to define the sizes, 50, 52, 54, 56, 58, and 61, is based on the stack of the bike. I mentioned this because we want to be true to the numbers we have. So the size 50 has a 500mm stack, and the size 52 is 520, 540, and so on. Then also very important about the geometry and the fitting is the idea we had from the beginning that we want to use standard components for this bike. So this bike is designed with a round seat post, 27.2mm seat post, and standard cockpit. That way, the 6 sizes and all the combinations of seat posts, offsets, and stem lengths you can have, this is ideal to set up any rider in the best position for the highest performance. Quite often, lately, many bikes, in order to achieve some bigger integration, they come with some more complicated setups for both seat post and cockpit, and it's not ideal, not always ideal, to achieve the best performance, the best position for the rider. In this case, it was one of the first requirements we had to keep it simple, to keep it light, and to keep it adjustable. Now, after that, talk about the geometry a little bit. Now, after we came up with that geometry chart of the ideal handling and fitting for the geometry of the Aurum Magma, we started to work on the 4 riding characteristics that would define how the bike would ride on the road. And these are stiffness, comfort, aerodynamics, and weight. For stiffness, well, I have to say, for all these 4 characteristics, of course, they are all related. So, and that was key in this case actually, because we wanted to find the best balance between the 4 of them. We didn't want to stress one more than the other necessarily, but to work together at the highest level, but always to work together. And for stiffness, as well as some of the other characteristics, there was a lot of work on the carbon layup. And carbon layup means not just the position of the fibers, but also the different types of carbon fiber grades we use, up to 6 different grades throughout the frame, also different resins, and also optimization for every size of the frame, because every size is a little different. From the size 50 to the 61, the length of the tubes is quite different, so the same layup would not work for all of them if we want to have the same stiffness and comfort characteristics. So the numbers on the bench for the stiffness test, they don't have to be, they are not the same for all sizes, but what we focused on was on the behavior on the road. So the rider experience had to be the same for all riders, regardless of their height. This is something that was paramount for Alberto and Ivan. As we said, they both ride the middle sizes, so that's usually, let's say, easier to achieve, to have a frame in a size 54 or 56 that is a good balance between stiffness and weight. However, when you go to smaller sizes or bigger sizes, again, things start to go a little out of the way, right? So we optimize the stiffness by different carbon layups and some design features. We use a BB386 Evo bottom bracket. This is the widest standard in the market, and is a really nice standard to create a wide down tube here, which really helps with the stiffness without adding excessive material, and also a wide stance for the chainstay, so we have a nice tail clearance and a nice support laterally when pedaling off the saddle. And this also allows us to make a down tube that is strong and tapers into the head tube, even like in this case, having a aero cross section for the tubes. So for every size, we have a different proportions of the down tube. This is very important because from a size 61 to a size 50, this length is very different. So to achieve a good torsional stiffness in the front triangle, which really is the key for cornering, for a good ride feel when twisting the bike. So it was very important to work on the scaling up and down the dimensions of the down tube, and obviously using a different layup especially on this tube and on the bottom bracket and head tube, depending on the size. Now, when we talk about comfort, it's also a characteristic that is very important, perhaps for a race bike like this one is. Some might think, well, it's not really the first thing you would focus on, but it's very clear that races go for 5, 6 hours, 7 hours, day after day, for a week, for 3 weeks. So obviously, comfort and being fresh on the bike is very important for achieving the highest performance of the rider. So in this case, we focus on a few areas like the seat stays to develop some comfort on the bike. We decided to go with a tall and long seat stay instead of a more perhaps trendy design such as it is now in the market to have a lower seat stays. The idea behind this is because with this design, with a dropout that goes with a seat stay that goes directly from the dropout to the seat post cluster, we have a bigger triangle, and also from the back view, this bigger triangulation connecting the rear axle with the BB and the seat post creates a stronger structure laterally when climbing up the saddle, left and right, but at the same time allows us to have this longer part of carbon that also, thanks with a special carbon layup, allows us for this to flex more under load of the rider and also absorb the vibration from the road better. If it was a smaller triangle, then we would need to reinforce it in order not to flex too much laterally, and that would affect also the vertical compliance. The fork, of course, is also very important as for the comfort. And so while this is an asymmetric fork, the left and right legs are different because of the front brake. So the front brake has a bigger cross section to withstand the braking forces, while the middle part of the fork legs and the steer tube, they have a layup that allows the fork to absorb the vibrations slightly. This is by no means a comfort bike. It's a race bike, but we really pay attention and spend time developing the carbon layup in order to achieve this good performance for the comfort as well. Then the following characteristic we work on very much from the beginning and in great detail was aerodynamics. So this bike, the Aurum Magma, it's a bike that is designed to be an all-rounder. It's a bike that it had to be the fastest in every condition and every terrain. It's not meant for flat roads or climbing only or any specific thing, but for everything. Alberto and Ivan, they always had a single bike to use for all races. And when they thought over time, when they were thinking to create their own bike, it was the target was to create one single bike that would do it all and would do it all at the highest level. So aerodynamics was something very important. During their careers, either they had in the beginning just a single bike to choose, or maybe at the end of their careers they had two bikes to choose from. One was a round tube light bike, the other one was an aero bike. So it was always that choice, but you couldn't have it all. And so now we focus on integrating some aerodynamics into this light and stiff bike as well. To do that, we worked especially in the front triangle of the bike and the fork. So we used NACA airfoils. You can see the cross section here of the down tube. This is the down tube of a size 56. As we said, every down tube is a little different for every size. It's optimized for stiffness and weight, but also aerodynamics now. As you can see, this is the NACA airfoil profile. And as you can see, the airfoil is cut. So we cut the tail of it as it's called as a cam tail. This way we can reduce the volume of the tube, which allows us to reduce the weight and also improve the handling of the bike with side winds because the tube is smaller. This shape is also very good for torsional stiffness on the down tube. So the aerodynamic work was focused on the front of the bike, the fork and the front triangle. From this point backwards, the air is dirtier and it's not so critical for aero development. So in this goal of having a balanced a bike that would be balanced between stiffness and weight and aerodynamics, it was important to decide in which tubes to work on for aerodynamics. So here we have a section. This is one of the test frames we used during development. And here you can see the section of the down tube, which blends nicely into the head tube, which also has a NACA airfoil shape, truncated at the backs. And you can see another aerodynamic detail of the bike that is very important. This is what we call the head tunnel. So the head tube has a tunnel inside to guide the brake lines, and it comes with this cap to seal it in the front. And so the brake lines, they run from the cockpit directly into the head tube. And we chose this design because it's the best way to achieve a lightweight, because the head tube is very close, it's very similar to a standard head tube, but also allows us to create a very clean front. The cables are, once everything's installed, the cables are really invisible, and also allows us to use a standard headset bearing and stem. So it's very easy to build. This bike is very easy to build, and it's also very easy to swap components and adapt it for different riders, different heights of the rider. Now the latest characteristic is the weight. So obviously this is a race bike, and weight is very important. But as we said, it was not the primary focus. It had to be balanced with stiffness, with aerodynamics. But anyway, every single area of the frame has, of course, been optimized for weight reduction as well. And that again goes with the choice of carbon fiber and the resin, but also with the construction methods we use. We use high precision steel molds. These are heavy molds that can be used at a higher pressure than usual, so that when we mold the frame inside with this higher pressure, this squeezes out more resin out of the fiber and creates a stronger and lighter structure. On the inside of the frame, we use mandrels. These are EPS mandrels covered with latex. This is a pretty high-end technology, and allows us to create a very clear, very clean inside structure. So everything inside the frame is very smooth and clean. Obviously here you can see different thicknesses of the carbon fiber, because some areas have more layers than others for reinforcement. You can see some different types of carbon fiber as well. But the idea of using these EPS mandrels covered with latex, even though it's a more expensive technology, creates a very clean and smooth interior, which translates in a stronger structure, and well, it also helps with cable routing, because everything inside is very clear and nice. When we talk about the weight, obviously we've been talking about the frame and the fork until now, which is the main. Those are the main pieces of the Aurum Magma. But we have to explain as well that the frame set is composed of around 30-35 different pieces, and we have developed every single one of them because, well, this comes from Alberto and Ivan. They couldn't have it in any other way. They are always achieving perfection. Everything has to be smooth and perfect and light and look good. So we work on every single part to be at the highest level, same as the frame. For example, the seat post wedge, which is very small, but we tested very much to use a low torque and no slippage. This seat post wedge comes with a rubber gasket to protect from water ingress. The frame is compatible with all drivetrains, so it can be mechanical, like this part right here, or it can be like for Di2. This is for the junction box of Shimano, and we also have a version which is blind for wireless systems. The radar hangers, we also design all these in-house. It's made of aluminum 7000 series, very strong, very light. Always looking for the smallest package possible. We have the top covers, headset top covers. We have two options, 8 and 20 millimeters. So the bike can be adjustable for everybody and still look good, still look integrated. Also important to notice, we supply this frame always with stainless steel headset bearings. This is sometimes overlooked, but we think it's very important for the function, the precision of the bike, and durability, obviously. So it's worth spending a little bit more on these bearings. And some other parts that sometimes, because they are hidden inside the frame or inside the bike, they are not paid attention to. It's like this headset compressor where we could reduce a lot of weight and also have a better function, and it's a very low profile. So once it's installed in the fork, doesn't really protrude. And once you build the whole bike, the cockpit, you are able to make the cockpit look very clean and nice. So these are all the parts and all the parts of the frame that we have developed. And Alberto and Ivan, they have been testing this bike for the last year in all conditions, in their home roads, doing some trips as much as it was possible during this difficult year. We also, during the aerodynamic development of the bike, we also took the chance to go to the wind tunnel in a few occasions. For example, this is a 3D print model of the beginning of the development. And so we had parts like this and complete frames that we took to the wind tunnel to evaluate the shape of the frame. The frame had been already designed using CFD software, computational fluid dynamic software. So we already had a good idea of the behavior of the bike, but it was very important to validate it on the wind tunnel, and so we did. Well, this is pretty much these are all the technical details of the bike, and you will also have the printed presentation and the PDF that you can check with any other details. And if you have more questions, please let us know and we will try to explain to you. Thank you very much. Bye bye.